Can the people in the room hear me? Can hear me? If anyone, okay, good. Yeah. Okay, testing. Video. Testing. Good. Everything is working today. Okay. Okay, let's start. Thank you. So what I plan for the Zoom meeting over there, if you have any question, I found out that actually students are more responsive in asking question in the Zoom chat rather than asking question like holding hands. Okay, so if you can, if you have any question during the lecture, you can actually in the Zoom chat actually write your question there. Okay, so let's start. Let's don't. So I think I just make sure everybody is in the room, right? So I think I start everyone publicly, privately. Just now, I think anyone in the waiting room? No more waiting room, right? Okay, good. So let's start. Okay. Okay. For the room inside here, physically room here, everyone can hear me, right? I don't need the mic. Okay. But actually, I don't. Oh, yeah. Actually, good. So actually the Pompoto's record this. Okay. Everything gets set. Okay. Okay. How is the quiz? My feedback is the first page of those expression is harder than the programming. But actually, I marked half. At least I marked the first page. The first page, at least, actually, everybody got at least half marks. I think, yeah. So it's okay. And I see the back. Actually, I just the difficulty is how to grade. Okay, I would say basically everybody got some ideas of how to do the flow. So I'm actually quite pleased. Okay, very happy about that. Yeah, at least I would say continue on that. I don't know what you want an A or what, but at least passing shouldn't be a big problem. Okay, in which last semester actually last 2 semester has 10% failure rate. Okay, 1 out of 10 fail. Actually, it's more than that even. Okay, but I think is going on like this, then everybody will pass. Okay, so I can maybe because I really do the quiz 0 and then scare somebody away. Okay, so which is good because I don't want to waste your time also. And you're staying, that means you have the ability to continue. Okay. Um, so the other small announcement is I put the wrong date on assignment 4. Okay, so assignment 4 start 2 days late and 2 days late. The deadline is 2 days late. Okay, but anyway, just follow that lah. Okay, the only not so good thing is then this Saturday actually will give you the assignment 5. Okay, there's an overlapping area, but I will see how. Maybe I extend the deadline for assignment 5. Okay, so you have more time. Anyway, the next week is I think it's already a PE, right? Is it? 29th, our PE is, yeah, 29th, right? Next week, okay? I think, yeah. So the 29th is the PE. So I will give you more details on the PE scoop and format and all this. Okay, and before that, I also will give you a mock PE. Well, not a mock PE. I just give you the last year PE. Okay, you just try the last PE and see what is the difficulty and so on. Okay, any question first? Okay, if no, then we continue. Last time we talked about lists and tuples and arrays. Actually, is a sequences. Today we'll further build on this idea. Okay, we'll see how much time I actually plan to talk about higher order function in Saturday. But if today we finish early, then we do this. Otherwise, we just leave it on because the higher order function I would say is some very mind-blowing stuff. Okay, it's a very, very difficult stuff. If you talk about the level of difficulty, probably that is the most hardest one in the whole course. Okay, so I will leave you have a blank, clear mind on Saturday. Then we start with that. Okay, but I open up the training tomorrow. Okay, for high order function. So if you want, you can actually try the high order function training. But if you don't, you actually can wait for Saturday to try the high order function training. Okay. Yeah. Okay. So, but today's is a bit conceptual. Okay. We talk about two topics. Plan to, if time permit, we talk about the higher order function. So we talk about a multi-dimensional array, and we talk about more on the details of how to use sequences, which is I have tuples and I have lists. Last lecture, I talked about how do you switch tuple and list, but actually there's more reason for that. Okay, so I'll actually talk about that. Okay, but let's go with some easy thing first. Okay, it's called multi-dimensional array. We introduce a package. I think we have been somehow mentioning package. I think everybody should already use some packages like math, right? But there is actually one of the cool thing about Python is they have a lot of ready-made cool packages, okay? And you can use it, it's like, wow, it's like another level of easiness, okay? So one that you will not omit is called NumPy, okay? Depends on how you call it. Some people call NumPy, it's more cute, okay? But NumPy, okay? But what I want to say is NumPy gives you a lot of convenient tools, but ultimately you can actually get around with it. Which I mean you can perform all the functionality, but just write maybe a few more lines of code. Okay, but NumPy, the cool thing is it gives you a lot of convenience. Okay, for example, let's say one of the example is, let's say I want to create a list by using 0 to pi. Okay, in which the interval is decimal place. Okay, in Python, if you want to do list comprehension, you need to do this. Can you do x equal to I for I in range 0 to 3.14? Range doesn't accept floating point, okay? I cannot say range 0 to 3.14, step 0.1. Python doesn't allow that. So the silly rigidness of Python for the range must be integer. You can step a few integers. Let's say every time I step 10, but you cannot step floating point numbers. So the range cannot accept floating point numbers. So if let's say I want to plot a graph from 0 to 3.14, but the interval is 0.1, I cannot use list comprehension directly. I need to do this. I need to generate the numbers 0 to 314, but then in the list I could divide it by 100. Okay, I can do this, but more conveniently, you can actually import NumPy. Okay, if you're not familiar with that, I can import NumPy. Because number have 5 characters, I think it's a very troublesome and clumsy. So I actually import as NP. So whatever I call NP is actually the NumPy package. So in Python, you use a dot to get something from the collection, okay? NP is a collection of all the functions. So one of the collection is called A range, okay? So be careful, it's A range, okay? It's not a range. We have an English word called arrange, right? A-R-R-A-N-G, but it's A range, okay? I don't know, is it for special purpose they design like that, or try to challenge your auto correction function, okay? So this one you have a lot of trouble. I make the slide if I try to type A range, auto correct me to arrange. But anyway, take care is A range, okay? Or I don't know what is the real meaning, but I would say A range. A range, you can see that is actually the meaning is range, okay? It's range, but the range is from 0 to 3.14 and step 0.1, okay? That's just a range, but this range allows you to use floating point. And then what it does is it actually have an array. You can actually notice a subtle difference. This array is a list, right? 0, 0.1, and so on. You can have this array thingy here, this word, okay? For now, you just accept it, okay? It's actually the NumPy list or NumPy array. It's not like the original list, but I would say it's like 99% compatible. Whenever you do a function, you do a whatever, you write a function that can accept the list, you can accept this, okay? So it's totally convertible. So in here, you just see it's a NumPy array, and you can try to see, oh, what is the length? The length is 32, right? It's very simple, right? Each time you step 0.1, the range from 0 to 3.14 is about 32 numbers, okay? But you can see that there was a little bit, maybe I don't want this because you see the ending number is 3.1. Let's say if I want to generate a circle, okay, I want to generate the pi as a circle. I don't want 3.1 to end. I want the ending number is 3.14 or 3.1415, something like that, okay? Then how? Okay, this one is generating a range from 0 to 3.14, but exclusive 3.14. I can do this. This is read it as I want to generate the number from 0 to 3.14, and the 100 means altogether 100 numbers. Is it okay? So I don't care what is the interval, but I don't generate 0 to 3.14. The first number is 0, the last number is 3.14. Every number have a equal intervals. There are 100 numbers. It seems more intuitive, right? I want 100 numbers that is between 0 and 3.14, and I don't need to care what is the interval. This will calculate. You can actually come up with the so-called the interval. The interval is actually this minus this divided by 99. Because you want 100 numbers, that's actually 99 intervals. Okay, so if you see that actually each of the intervals, each of the difference between two numbers is 3.14 divided by 99. Okay, but the number is seems messy, but if you want to plot graph or whatever, actually it's quite useful. Okay, again, the function name is called lin space. Okay, it's not line space or linear space. It's just another weird name. Okay, so don't know why NumPy do that. Okay, so we can create a array like a list. For example, after you create this NumPy array, this actually will create a NumPy array. You can actually create an array like a list. Okay, for example, you can actually convert the list 1, 2, 3 into a NumPy array. Okay, you can see they actually almost work the same. Okay, in the list you can actually say A00 equal 99. You actually change that. Okay, but on the other hand, you can think this NumPy array is actually the list, but it's an enhanced version. It's like Iron Man. Iron Man and the first movie is Iron Man, okay? And then second, you have Iron Man 2, Iron Man 3, and then it's more powerful and whatever, okay? So it's actually you can treat it as an enhanced version of the list. And if you check the type of the A, which is the NumPy array, actually it's a class NumPy array, right? So, but if you check the list of 1, 2, 3, it's actually a list. So the NumPy array and the list is actually different. You actually see that the type is called ND array. Actually, later you know that ND stands for n dimensional. Okay, you can actually have more dimension. Okay, so far okay. Nothing actually very cheap here. Okay, just introduce another type of list called array. One thing I think quite cool about Python is called broadcasting. Okay, let's say if I have an array, can I do this? Remember, if you have a list, you cannot. Let's say if A is a list, not this NumPy array, right? If a list add one single number, you cannot. But what does it mean here? Every member plus one, okay? It's a bit non-intuitive types of notation. But if you do NumPy array to do something that is not for the list, NumPy will actually, sorry, okay. Thank you. Can I actually, there's a method to switch or, yeah, I can actually put partition into waiting, yeah, so they can directly enter, okay. Good, thank you. Yeah, so that was actually, if you have NumPy array and you try to do some operation on the NumPy array, that is not for the list. NumPy array will try to fit the operation in every single entry. Okay, so if this +1, you cannot +1 to the whole list, right? But you can +1 to every single element. So NumPy will actually try to find what is the lowest level, actually not the lowest, the highest level, and apply to it. Okay. For example, this one. Yeah, I need to choose it. Okay. This is called broadcasting. Okay, it's like I distribute. It's like radio. I don't know. Sorry. Nowadays we don't have radio. Radio, the real radio. The real radio in the old days is you have a tower, you have all the signal to everybody, and you have the radio receive the signal. Okay, so it's that concept. For example, I can say A times 3. Remember what does the times 3 do to a list? If A is a list, A times 3, what does that? What would that be? It will become 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It becomes a list of 15 entries because you multiply the list 3 times. But this, if it's a NumPy array times 3, it means I get every number times 3, which becomes 3, 6, 9. Okay, so you can actually treat this times 3 as some kind of operator. I throw this operator to apply on everything. Okay, and different from list, and you can do this. So now, can you try to interpret what is happening? I want to say if the list is bigger than 5, okay, a list cannot be bigger than 5. So I would actually try to compute each of the entry is bigger than 5. So 3 is not bigger than 5. There's 4. 6 is, sorry, this list, okay. 1 is not bigger than 5, and all is not bigger than 5 anyway. Yeah. Okay. And a single operator with a single number at the right side that actually apply the operator to every single entry of the array. Okay. Any question first? Okay. So you can see, well, I can use some for loop, or I can actually construct another list, whatever, to achieve all this purpose. You can actually write code for that. But NumPy just let you to do this 3 characters, then actually perform the thing. Okay. Yeah. So actually, what you can deem it is this is some actions, and you actually apply to every single element and produce a new list with that action taken on everyone. Okay. Okay. You can add 2 arrays together, but you can see that there's a difference with your list. Okay. List, if you have one list plus another, you have a longer list. But now it acts like the mathematic vectors, x, y, z plus x, y, z. Okay. So it's just a vertical adding 1 plus 4, 2 plus 9, and 3 plus 16. So it's different from a list. Multiplication is like a bit like the dot product. I don't know whether you remember dot product, but anyway, it's 1 times 4, 2 times 9, and 3 times 16. Okay. Sorry, say again. Yes, for this operation, yes. Yeah. Otherwise, I think it will be errors. I didn't try that, but normally I do it with the same element. But if different elements, so probably will give you an error. Yeah. I think I have an example later that telling you you cannot do that. Yeah. So the question just now was asking, does the 2 lists have the same elements, the number of elements? Okay. What? Yeah. Can NumPy store elements of multiple types? If not, why not? I never tried, because NumPy usually I do it with numbers. I don't remember that. Yeah, I need to check. Yeah, because usually when you use NumPy, you probably use it at the numbers. Okay, that one I need to come back to you. Okay, but it's a good, yeah, it's a good question. I leave it alone and then later I try. Okay, yeah. If not, why not? Maybe because the name is called NumPy. It's for numbers. Okay. Square root, I can use NumPy square root to square every numbers. Okay. Square root every number, or dot product, V1 dot product. This is actually adding up this. Okay, if you remember what is a dot product of the mathematic dot product. Okay, actually it's the sum of 2 vectors multiplication and sum and so on. Okay, so you can actually look out the NumPy. Have a lot of very easy function. You can use one function to compute a lot of things. Okay. More of this function, you actually go to the SciPy. Okay, actually it's under SciPy. SciPy is even one more level. NumPy is for manipulating all the numbers. SciPy, even I think they have some Fourier transform, all those methods. It's just one line, you can do whatever you want. Okay. Yeah. Okay, introduce NumPy I did a bit. I will use it for the two-dimensional array. Okay. What we learned for the list and tuples so far is we treat it as one-dimensional array. Okay. So what happened is what actually anyone knows what dimension are we living in now? Are we living in a three-dimensional space? If you talk about the space, this is right. You can actually go back and forth, left and right, up and down. Okay. But there are people saying that actually, if you go to this as a XKCD, I don't know anyone read the comics. It's a romance math geek comics. Okay, it makes romance with math. Okay, yeah. Anyway, but it's talk about if you talk about the base Einstein whatever. Actually, they say that we're actually living in the fourth dimension. Real time is a dimension, but actually, no one proves that time is a dimension. Actually, yeah. And if you talk about string theory, whatever there is, I think it's 26 dimension or something like that in life. Okay, so that kind of thing, I actually don't know how much dimension. Okay, but let's talk a bit simpler. Let's say what is one dimension. Okay, anyone went to US and lived in motel before? You know what is a motel? In US, we have this thing called motel. Okay, motel means mobile hotel. A bit different in US is when you travel, usually people drive themselves. They drive a car. So the longest drive I drove it from Illinois to Florida, 17 hours straight. Okay, if you cost, usually people don't that 17 hours, right? People like after 8 hours they actually rest. So how do they rest? Actually, these are the motels, which means they just have like a very simple facility motel around, and usually very cheap. Okay, I remember that time it's like 20, 30 US dollar per night, something like that. Okay, usually it's a lot cheaper because they have no facility. Okay, and they're very simple. Okay, they don't even have a second floor, so it's actually a very plain room with shower and whatever. It's almost like a hostel. Okay, so it's because it's so simple. If you let's say I only have like room 1, room 2, and room 3, and so on, right? So it's very simple. I just have one dimensional. So which room you go? I go room 3. And what is the next one? Is room 4, right? But there's a very basic and simple hotel. But you know, if you have so it's one dimension. You can only go left and right. Okay. There's the hotel you cannot go up and down. Okay. But let's say Legoland. Okay. Or actually normal hotel. What do you have? You don't only have one level, right? For example, you have the first level, and you have some rooms 1, 2, 3, 4. Okay. But that's not the end. Usually you have more than one level. So like level 2, level 3, level 4, right? And they may have the same number. So what happened is I can say I actually live in level 2, room 5. Then it's actually two dimensions. One dimension is actually the floor numbers, and the other dimension is the room numbers. Okay. In which this kind of structure is you actually use two directional index to actually label your position. We have a lot. Anyone play chess here? So if you do chess player, they actually remember all this. Okay, so each checker, for example, this queen is now at d8. Okay, and some people can play chess without this graphical visualization and just tell them d8 to d4, a5 to a3, whatever. They actually can visualize in their mind, and actually people can play chess like that. Okay, they just use an index. Okay, I remember this Hong Kong mafia movie. They said this guy can blind spot and then play 3 chessboard together and still win. Okay, but anyway, not possible. Okay, okay. But anyway, what more my key point is you can actually represent the whole motion by just the index. Okay, for example, this is row 8, and then the column D, then you got D8. Okay, so you two index. Actually, we use it a lot of time, right? Excel. I think everybody have some experience with Excel. So each cell actually have a row and column. But the good thing is Excel don't confuse you. The column index is alphabet. So it's column A, column B, column C. The row index is numbers. It's 1, 2, 3, 4, 5. Okay. Imagine if both of them are numbers. That's what happened in Python or other languages. Okay. So you say the position 2, 3. Is it row 2, column 3, or column 2, row 3? Okay. So that was the big question. Okay. So this one is row 8 and column B. So it's B8. Okay. So one-dimensional array, usually we use it in our programming language. We store a lot of items, okay? But two-dimension, for example, we actually say the sixth item, which is index 5, is Smith. And two-dimensional array like that, okay? So you actually need to see the fourth row and the one column, the index one column is Mary. Sorry, is it Mary or Fry? Okay, yeah, okay. So usually let's watch other language convention. In Python, if it's a two-dimensional array, remember this: row, row, row your boat gently down the stream. Row first. Okay. If you don't remember I sent this ugly song in the lecture. Okay. Row go first. Okay. Row go first. So if you read 4-1 for the fourth row and the row with index 4, which is the fifth row, and the second column. Okay. Yeah. So for example, this one, NumPy has this function called zeros, which means you allow you to create an array of 3 rows times 5 columns. Okay, in which you actually can see that you can get around with lists. You just see that it's actually a big list with 3 items, and each item is a list of 5 items. Actually, you can totally do it with a list of lists by yourself without NumPy. Okay, it's basically the same thing. But usually this one you can see one line of code, then you generate this. Okay, of course you can use list comprehension to use our normal list to generate this. Okay, if you use normal list, you can see you can say yeah, you can use 2 double so-called list comprehension to generate this. Okay, you have 4. Well, okay, but anyway, this one is generating this, right? I just can read the whole thing, but probably no one will understand. Okay. For example, I can actually change any of the items. For example, this one, 1, 4. Okay. You can see 1 is the row index 1. Okay, and then your column 4. But you can see it's actually the position, the row number, the second row, and the 5th position. As we all remember that index start with 0. Okay. Yeah, so it's row is and then it's column. So far, okay? Yeah. So for example, you can even do this, okay, in NumPy only, but because sometimes too many blankets. Actually, later we can have even high dimensional array. You have a lot of blankets, okay? You can actually just do 1, 4. It's just a notation. It doesn't add any functionality, but just saying that they are equivalent, okay? You can create your own array in which this is actually a list. So without NumPy, I actually can create a 3x4 array like that. Okay, so without all this is actually a 3x4 list in normal Python without NumPy. Okay, and I can actually do slicing. Wow, what slicing? Sequence slicing. Okay, what does that mean? Row I want 1 to 3 and column 2 to 4. Okay, this is the original one. 1 to 3. Which row to which row? 1 to 3 is you start from the second and until the end, right? Is it okay? Starting from row index 1, which is the second row, until row index 3, which is the 4th row, excluding 3, is the same string slicing or sequence slicing rules. So I want all these rows. And then I want this column, 2 to 4, in which is this. 2 is the 3rd column, and until the 5th column, okay? But before the 5th column. So at the end, this will output. Sorry, need to upgrade, okay? Okay, sorry for the Zoom people. I will switch you to another meeting, okay? Is it running out? Soon 10 more minutes, okay? So we tahan for the 10 more minutes, okay? Okay. Okay, so at last, the output for that is 7, 8, 11, 12, because it's that one, okay? Okay. Another example, 0, 2, 2 colon. Anyone tell me what is it? Or just tell me how many numbers would that be? No audio. I'm still speaking. Hello. Okay. Let's try to make sure this is still working. Okay. Yeah. Okay. So 0 to 2 is the 0 to 2 row. Okay. So it's 0, 1. The 0 row and the 1 row. And 2 after is the 2 columns and the 3 columns and afterwards. And that's why I get 3, 4, 7, 9, 3, 4, 7, 8. Okay. So it's a bit like puzzles. Okay. And how about this? Why? What does just 1 colon means? Everything, yeah, all of them. So everything, every row, that means. And then this 2 colon 0 colon 2, starting from 0, ending at the end, but step 2. So I actually got this and this, right? And finally, I have this array. Okay. So yeah, there is you can actually use slicing in all this NumPy array, but you cannot do it in a normal list. Let's say if I declare a list just like that, I cannot do that. Okay, this is what NumPy cool stuff. Okay, and you can do 2 matrix and multiply them. This is the real matrix multiplication, in which I think most of us forget what it is, right? But anyway, I don't care. Okay, that is the good thing about programming. I don't care, because if I need to use matrix multiplication, I need to use it. I don't care how what it is. Okay, so yeah, I could just use it like that. But just answering just a question, if let's say even matrix multiplication, you need to have matching the dimension. If you don't match the dimension, you have some errors. Okay, the shapes errors. Okay, yeah, and even with this multi-dimensional array, you can do broadcasting. Okay, so you can see I want to have this array and I want to compute a larger than 5. Then I just check every entry, which entry is larger than 5. So for example, 1, 2, 3, 4 is all false until 6 is true, right? So I actually have an array like that. And I can actually print, wow, what is this? Actually, for this, I will actually pick the true index and print out the list. Okay, this is going a bit haywire. Okay, I won't recommend this kind of thing, but because it's already like you need to break the 2-dimensional array and come back to 1. Okay, but I just want to show that you can actually do this very complicated thing with 1 line of code. Okay, I would recommend at this first level, if you really want to do this, you actually try to look through it and do some of your own code to do it instead of using this. Okay, but if you are advanced enough that you can actually use NumPy like a master, then you actually try this kind of thing. Okay, yeah. Okay, for example, I can just do this: print A such that A is larger than 10. Then just get a 2-dimensional array and you find everything in that's larger than 10. Okay. Multi-dimensional array, okay? I thought we already got multi-dimensional array. Sorry, just now it's 2-dimensional array. What if I have more than 1 dimension, okay? This is 1-dimensional array on the left, and this 2-dimensional array on the right. 1-dimensional array, you have 1 direction. 2-dimensional array, you have 2 directions, going up and down, and left and right. Okay? What if you have 3 dimensions? So you can actually go up and down, you can go left and right, and you can go back and forth. Okay? Wow, what are these? Okay? Actually, it appears in a lot of real daily life applications. For example, there's actually other names in business. Okay? In computer science, we call them a multi-dimensional array. But in business, you have this multi-dimensional data model, multi-dimensional analysis, or multi-dimensional data box, or whatever. Yeah, actually other names. But at the end of the day, is our array. Okay. So what happened? A multi-dimensional cube. Okay. At the end of the day, we actually do have those data in our daily life. For example, this is, let's say, some people's budget or whatever. So or the sales record. So you can see that on the left to right, each column represent in the year is a quarter 1, quarter 2, quarter 3, or quarter 4. And then for each one, you have actually quarter 1 emails, quarter 2 mails, quarter 3 telephone, whatever. Or then is a bill, okay? And then for that, you actually divide it into camping equipment, golf equipment, whatsoever, okay? So each one, I actually have a 3-dimensional array to store each of the data. I think this is not a very good data because it's not very easy. For example, this one is easier. For example, this is actually the sales cube, okay? So my sale to each country. For example, my product is selling to Spain, France, and UK. And then actually which type? My company actually sells book, sells bike, or sell clothing, right? So I can actually check if you only take this as a 2-dimensional array. For example, I want to ask, what is my company's clothing selling to France? Then actually it's one entry of the 2-dimensional array. But this 2-dimensional array are duplicate for each year. So I actually can have the 214 record, 215 record, and 216 record for everything. So it becomes 4-dimensional array. Okay. Sorry, it's a 3-dimensional array. And how to make it 4-dimensional array? I can actually do one of these cube is the actual sales. One of them is a projected budget. Right? Each entry. Then I can actually ask, what is my projected sales, or what is my actual sales on 2015 of my clothing sales to France? Okay, so you actually have all this data like that. In which, actually, you think about it, we all use this quite a lot of time. The normal thing is movies. Movies, think about it, how many dimensions is one movie? You can think of a movie one frame, right? One frame, how many dimensions are there? Are you sure it's 2? Why is it 3? Because you have X and Y, but each pixel have 3 colors. RGB. So each one picture is actually a 3-dimensional array. Actually, it's a real implementation. We actually, if you have time, we actually will teach it in the last lecture. Okay. Each one picture is a 3-dimensional array, which exactly like this. You actually deem it as this is X, this is Y. They actually see one picture, but actually you have the RGB channels. Exactly. So if you have a movie, then you have this cube for every frame. Then you stack it for time. Is actually a movie is a 4-dimensional array. Okay. So one picture is a 3-dimensional array, unless you do, let's say I want to do a black and white movie. A black and white movie is a 2-dimensional array because each pixels you only need 1 numbers. And a black and white movie is a 3-dimensional array, which is easier. Okay. So we actually have a lot of this in daily life. So you can think about that. Okay. So a 3-dimensional array, like a picture, n times n pixels, and each of the pixels is the RGB values. And actually not next week, I think it's next week, we actually try to do this. You can actually read in pictures and generate this kind of thing. Okay, this is the code to read in the pictures. So this picture can be any picture you want, but you can actually just read in the cat pictures. And this is actually a 3-dimensional array. What I can do is, you can see what is it. This is the one single line I make from